combustion thing. Photosynthesis is another thing. I try and fill the gaps, what's not being taught. Here's a good trivia question. Photosynthesis, what's it do? Takes what out of the air? CO2 out of the air and the water up from the soil. Emits what? Where does the oxygen come from? The CO2 or the water? Water. Most people think CO2 because they're looking at the O. So you got to know that reaction, that water is the one that's splitting up. And I had this, I minored in biology. I got a BS in chemistry, minor in physics and biology, AA College of Marin. So I have a research degree in chemistry, and it only took me 3 terms to get it. Reagan, Bush, and Clinton. I'm serious. 2 of those were doubles, remember? But I got a good education. I learned the biology. So my biology teacher's up there, and she even had it backwards. I'm like, the electron, she's moving hydrogens and not following the bouncing electron, you know? And I'm like, come on. And she's like, oh, it's not important. And I'm like, that's the whole crux of the reaction. And here's a biology professor at State, not College Marin, you know, promoting that kind of stuff. So that just fueled me. I'm like, if this is why our science education is getting so bad, my biochem teacher, same thing. He was doing something with molarity. Well, I was a chem major, so I had to learn that. And he goes, oh, biochemists are sloppy. You know, it's like he wasn't doing his sig figs and significant digits and stuff. And I'm like, well, don't teach me your bad habits, you know? So I stuck to the rules, and now I'm fanatical about it. What was I going to show you? The photosynthesis? Now, you can do photosynthesis with the balloons. And it's one of the most simplest reactions that it starts with. I have dogs. One of them, I can't even talk about, but I don't have her with me. Rubisco is her name. Anybody know what Rubisco is?
Yeah, it's photosynthesis.
That's the short name. What's it stand for?
Sugars.
What is it? Ribose, bis, phosphate, carbon dioxide, oxygenase. See, he knows that. Rubisco. So when I named the dog Ruby, which is also, you know what Ruby is? I recycle. Ruby is an aluminum, it's an impurity in silicon dioxide. So I'm like aluminum, and Ruby would pick up the cans when I go recycle and stuff. But Rubisco, it's the most abundant enzyme on the face of the earth. And how many people have heard of it before I just said it? You might remember hearing about it, but and believe me, it took me 3 months to be able to say ribose, bis, phosphate, carbon dioxide, oxygen, ACE. Whenever it's ACE on the end, it's an enzyme. So now I'm on this biochemistry kick. Let me give you an introduction on the chart of the nuclides, because this is the last thing that I did. I got a research degree in chemistry, like I said, right? I didn't know where carbon came from. Where's carbon come from? Do you know where it's made? What stars? Our sun? Maybe eventually, but our sun now, anybody know what our sun's doing? From what? From hydrogen. Okay, so how many hydrogens? What is hydrogen again? Do you remember? This is what I start with the kids. It's most typically, see, this will show you all the types of hydrogens with the neutrons, but I'm not going to start with the neutron yet. Hydrogen is 1 proton and 1 electron, right? What's bigger, a proton or a neutron?
Bigger in size or bigger in mass?
Same thing, isn't it?
Are you talking about proton or electron? Because you just said
Proton.
proton or neutron.
I do this with honors chemistry kids in high schools, ritzy high school. Half the kids will say a proton is bigger than a neutron. My point is, you said helium is 4 protons? Because it's making helium out of protons, right? So what's helium? How many protons in helium? 2? Wait a minute. The sun is making helium. And helium's got 2 protons? And what's it making helium out of? Which is what? 1 proton. So how many protons does it take to make a helium? 2 protons. Is there anything with just 2 protons together? Never happens, does it? This is the most fundamental thing. This is what I'm talking about. Right at the beginning, we go in and teachers are teaching this whole chart of the nuclides, all this out here. Right at the beginning, step number 1, protons. The history of the universe, I won't go into the quarks stuff unless you want me to. The history of the universe says the big expansion, all this went out. Hydrogen, the most predominant element. Gravity, condensation starts coming in. The first star, like our sun, takes hydrogen, which are all protons, and what's it make? See, nobody knows, right? Critical thinking. Teachers don't like to test it. 2 protons, and what else is the most predominant helium? The alpha particle, they call it, right? 2 protons, 2 neutrons. What's bigger, a proton or a neutron? So how does it take 4 protons and make essentially 2 neutrons? Have you ever stopped to think about that? And I talked to the astrophysicists and cosmologists and astrobiologists and all that, and oh, it isn't important, details. Astrophysicists are sloppy. We're making mass, right? The sun right now is taking 4 protons and it's making a net equation into 2 neutrons, 2 protons, plus energy, right? It's releasing energy. How does it do that? Most fundamental, and we're not even to carbon yet. This is just step 1.
I thought that's where it takes the proton, emits photons of light and converts it to neutrons.
Emits photons?
That's what I thought I was.
You're like the closest to anybody else say anything on it? Because a photon definitely can carry energy, and it's close. It's almost close. But no, don't. I'm proud of you. I'm very proud of you. Because at least you're taking a shot at it, right?
Is it emitting a positron?
Positron. Now, what is a positron? Pardon me?
Positive electron.
Positive electron. That's antimatter, isn't it? The first reaction in our sun right now is creating antimatter. The only way you can make mass is called pair production. So a positron has all the mass that an electron has, but its electromagnetic charge is opposite. So what does the sun do? This is everything that they teach in introductory in one little lesson here. It takes the energy. What's the temperature of the sun? 15 million degrees roughly, okay? At 15 million degrees, you can take 2 protons, stick them together, and what you get is 1 proton. Okay, I'm going into my quark theory anyway. I gotta do it. What is a proton? Anybody know what makes up a proton? This is well known now. This isn't science fiction, like antimatter. Antimatter, no more. Of course, it is interesting. You got a humongous top quark, humongous bottom quark, and the force carrier for that is called a tau. Anybody ever hear of bottom quarks? You've been to SLAC? They've been making these for 15 years. Bottom quarks, 3,000 times the mass of a proton. It's just 1 quark. And they make the B-bars they call them. And if you type in babar on the internet, B-A-B-A-R, you'll be at SLAC. Because they're doing matter-antimatter collisions. They've been around 280 for 15 years. So antimatter is no more science fiction. Quarks, this is what makes up matter. Proton, neutron, out the window, okay? No more. The next thing over, have you ever heard of charm? Or more yet, strange? Remember what was strange? Have you ever heard of Murray Gell-Mann? They were doing these particle collision things. It started with the cyclotron. That's why it all goes back to Lawrence. They were doing nuclei. Well, pretty soon, there's a guy I call him Burton Islet Electrons Richter because he was, colliding electrons. And I used to wonder, how can they do it when they're so tiny, right? Well, the faster they are, Einstein, the more bigger and massive they are. You accelerate a proton to even like 0.6 C, that thing's humongous. It's going to hit whatever it goes into. I used to think, how are they going to shoot little electrons to get them to combine? You accelerate them, they actually get bigger. Einstein, right? Charm, strange. Have you ever heard of a muon? I did that backwards. Muons, up, down. Muon. Anybody heard of muons? This is part